Our next presenter is Robert Harber. He assumed the current role as the Rocky Area's Vice President in September 2016. He's responsible for the business development operations in the Rockies area for Halliburton. Prior to this role, Robert was the Director of Completions and Productions in the Northern region. Robert began his career in June 1994 as a well site engineer. From that point, he has held various positions in engineering and sales and operations. He previously roles as area and operations manager and business development manager. And you guys are going to like this presentation. This presentation was a derivative of a hunt that Harold and I and Jeff Miller, the CEO, and Rick Moncrief, and let's see, Harold, who else did we have with us? And Jeff said, I'm gonna send a guy that's gonna start talking about how we're to get more barrels per foot. That Bakken resource is incredible, and that's what we're down to. So please welcome Robert Harber.
Thank you. Good morning. Tough to follow Lynn on that. So lucky to have advocates in the state of North Dakota like Ron and Lynn. I think if we had those in every state, it'd be just absolutely fantastic for our industry as a whole. I've had the pleasure of working in the Rockies area, as we term it, for about 22 years. And when I first showed up, this was pretty much a gas area, right? I mean, when we think about it, we had Southwest Wyoming, we had Peon's Basin going, and Uinta Basin. Same, throwing the coal bed methane operations that were going on down in Trinidad, Colorado, San Juan Basin. And then there was, oh, by the way, this little operation happening up in North Dakota at the time. And a few years later, here we go. We've got the first wells being drilled in eastern Montana, and we don't have to really talk about kind of what happens next at that point. So we think about the timeline here. Make sure I get. Too many. Okay. So thinking about the timeline, not surprisingly, over the past 2 decades, the Bakken has undergone a tremendous transformation. Many of the lessons learned, innovations, and technology developments that exist in our industry today across North America and the globe have roots right here in the Bakken. Being in the forefront of the shale evolution in North America and the globe, these innovations and learnings allowed many other shale plays to start with a major leg up because of the things that we learned right here. So be proud of what this area has done and the innovation that we've been able to create during that time. We think about early on lifespan, we had barefoot completions to start off, and then we went into sliding sleeve technology. And all this was innovative as we went along the way. But we quickly moved into plug and perf operations, coupled that with zipper fracking, and all of a sudden we had a very efficient operation that could more effectively stimulate these wells and extract more oil out of each well that was being produced. Drilling fluids, motor technology, drill bit technology allowed us to get out farther and faster. Lynn referred to just a little bit earlier about 200-something rigs. It wasn't uncommon back in the day to think about maybe 40 to 45 days to drill a well, and now we're drilling them in a week very commonly. When we think about other aspects of innovation, maybe a little bit more subtle, but they're behind the scenes, but they're really important. We think about remote systems that we use these days. It gets our people out of what we call the red zone, gets them out of that danger area, keeps people safer. We're also using a lot of automation and artificial intelligence behind the scenes that you may or may not see to actually improve the reliability of all of those operations. This is kind of prolific within our industry, right? But these are tools that are very important for us. I'm going to touch on that a bit later as we get into it, because we'll move beyond the surface to the subsurface. Second here. Okay. All right. Hopefully that didn't go too far. So one of the advancements that I want to touch on real briefly, kind of going back for a little bit of history, is simul-frac. So just for those that may not know what that simul-frac is, it's fracking 2 wells at one time, just as the word implies. This was something that was actually started back in 2017 with QEP, which is no longer in existence today. But it was drawn up on a napkin, like these things a lot of times happen. And the idea was born at that point. And this was actually at the time was using kind of two technologies that are important. First of all, it was introducing that simul-frac concept for efficiency in order to get the most out of the equipment on location, but it was also refracturing wells, which is something that we'll be talking about a bit more as we go forward here today. But when we think about that, it was pretty small at the time. They weren't tremendously high rates. It wasn't, ultimately that difficult to do once we kind of got through the logistics of how we're going to make this work and how we're going to, make sure we can pump in 2 wells at one time with one set of equipment. However, this is now taken off. This is a primary completion method that's now being used in the Permian Basin as an example. It's growing some speed up here. It has a bit of a challenge up here. You need certain size pads. You need a certain size, number of well configuration on location. But nonetheless, this is an innovation that was born here. We've got companies now doing what we call trimul-frac and quad-frac. And the goal was to get to Cinco de Fraco by Cinco de Mayo. I'm not sure if we actually made that or not, but I got to check in on that. Okay, so if we zoom out a bit, and again, you all know this and you've heard it, I'm sure, numerous times. I can't probably do complete justice to this. However, when we think about the broader global picture and the continuing need for growth of the products that we're responsible for bringing to the market every day, it is very important that we continue to do the work that we're doing and continue to find ways to extract. So we hear a lot out there about, moving to alternative forms of energy. Great. We need that. We're going to need everything. As the chart kind of implies there, you're going to have a growth of that. We can't ignore that. But when you think about it, you can't turn on the TV, the news today, without seeing stories about the skyrocketing demand for power associated with the proliferation of AI data. The stability of some local grids, as we saw in Texas a few years ago, is already having some problems. And that's before all of this demand even comes on. The war in Europe, the war in the Middle East, all of that's changing, and the increased demand for plastics to go lighter, to change packaging materials, all of those things are pushing us forward to needing more and more of the products that we produce. So in nearly every way, the world is changing, and that key to affordable, reliable power and energy security, visas come with a modern society, they all start here. And when we kind of think about it, what makes a third world country become a first world country? Well, it's access to affordable energy. We're lucky in that regard. Some countries aren't, but that creates opportunities for export and whatnot. So despite the EIA's the stated policies case, which is the most pessimistic, as you can see up there, it shows an actual decline in our share of the energy market over time, but we're still going to grow. We're still actually going to grow in the total volume that we have to produce despite a market share decline. And then if you want to look at OPEC's case, they actually showed it as a more aggressive case in our favor. All right, so let's come back into Halliburton for a second. So threw up the value proposition up here. It's really important to us. This is kind of the lifeblood of what we do. But at the root of what we do, we collaborate and engineer solutions, maximize asset value for our clients. So what does that mean? And how do we think about that in terms of why does it matter here? So every day, what we're working on at Halliburton behind the scenes is trying to figure out how do we extract more? How do we get more? How do we help our customers get more from the reservoir? How do we make these operations more efficient, more effective, more cost-effective as we go forward? Because as we all know, the competition for capital is fierce right here in the U.S., but also globally, and we've got to make sure that we're very competitive right here in the Bakken. So what are we doing in order to try to help push that forward? So it brings us to some challenges. So when we think about the challenges, again, these aren't profound, but at the same time, these are the things that we kind of want to boil it down to the basics. What do we need to do? So maximizing production. How can we continue to move forward from a maximizing production standpoint? We do hard things in this industry as a whole. And we like doing hard things. That's what we're here for, and we excel at it. And we show what we can do once we kind of put our minds together and all the innovation that comes out of that. But we're constantly thinking about, how do we maximize production and profitability? And a lot of times here in North Dakota and in other places, we'll talk about Tier 1 or Tier 2 or Tier 3 type acreage. The Tier 1's the easy stuff. Easy, I call it that way. But it's the most productive. And then the Tier 2 and Tier 3 is much more economically challenged. but how can we continue to drive those economics forward as we move away from less Tier 1 acreage into the Tier 2 and Tier 3 and make that economical, make it competitive against places like the Permian or other locations that are competing for that capital. And then also, how do we effectively maintain all of these wells that you have drilled and put into a production mode in order to maximize their lifespan and to continue to improve that recovery? So today I'll share some of the approaches that Halliburton is taking to help our customers address these challenges by transforming the service delivery model through automation and virtual remote operations, supporting our customers' sustainability goals, and then also innovating those solutions to help maximize the existing asset production. All right, so let's start with the first challenge. How do we increase the certainty and maximize recovery in Tier 1 reservoirs, but really more importantly, as we move forward to the Tier 2 and Tier 3, where the economics are much more challenging? While many may think of Halliburton as at that surface level, the horsepower, the trucks, the people, all that type of stuff, for many, many years, we've been incorporating a lot of very sophisticated, high-end technologies on the subsurface in order to try to bring that together. So in a way, think about it like the physical and the digital world, and how do we actually bring those together in order to improve? That subsurface insight speeds decision-making and helps to reduce the risk. So when we think about across the different arrays of entities that we have, we bring together that physical and digital, combining the electronics, the data analytics, machine learning, and I know these are all kind of like the buzzwords these days, right? But it's real, it's happening. And then obviously automation with the goal of creating a competitive advantage for our clients. All right, so Octave, intelligent fracturing platform. So why does this matter? And I'm going to talk about this a little bit, but I want to kind of put it in terms of maybe thinking about your operating system on your phone. So we need a backbone, we need an architecture, we need a structure in order to be able to do the things that the technology out there is actually capable of doing. So we've been in the process of transforming our fleets into this newest, latest, and greatest platform. When we think about all of the things happening on location, and they're not novel, I mean, there are so many sensors on location, there's so many trucks, there's so many different parts, moving parts, pieces, and everything. How do we improve the life of that? How do we make that go further, do more, be more cost effective? On one frac job alone, we might have as many as 5,000 sensors collecting terabytes of data during that job. No human can possibly analyze that, right? So we have to kind of move into this platform of using AI in order to try to figure out what does that matter. So what does Octave do? Well, it takes the data, it processes it, does three things. First, it can automate the entire operation on location to maximize the performance and efficiency of all process and service equipment. So think about this in terms of it can diagnose transmission issues and say, hey, we need to take this truck offline without a human having to intervene with that. It can optimize rates on different trucks in order to make sure that we're getting the most lifespan out of those trucks. And again, why does this matter? It's about reliability. It's about uptime, reducing non-productive time, being able to pump more, do more with the equipment that we have, and reduce the total number of capital investment and assets that are needed on location, which lowers cost of producing those barrels. The second thing it could do is help synchronize the work and operations, maintenance, engineering, and supply chain all at one time. So that's a lot, actually, when we think about it, as far as all the moving parts go and all the different disciplines that come into putting these jobs together. And then through remote monitoring and control, it does provide instant insight into job progress and performance, and gives performance to decision makers who may be at the rig site a few miles away, or Houston, Oklahoma City, Dallas, Florida Keys, wherever they want to be able to actually remotely operate these jobs. And again, this isn't trivial, because this is something we've talked about for a long time, but it takes a lot to actually get this going. And we're actually on the edge of actually doing this across our operations in North America today. The platform actually provides a way for clients to go in and put their parameters in that they actually want to see on the job, and then the equipment will actually run to those parameters. For instance, if you want to treat it at 8,000 PSI on a well, it'll actually run the equipment to treat the well at 8,000 PSI. So it'll make those adjustments during the course of the job. And again, that doesn't necessarily sound like it's that big of a deal, but when we're looking for consistency and we're looking for design and we're looking for implementation, all of those things do matter, and it drives that consistency forward and improves the process overall. Again, think of Octave like the operating system, like the operating system on your phone. So then what do you really care about? Well, you care about apps, right? I mean, the apps is what you want to run, and you want to make sure the operating system can run the apps that you have, so that's Octave. But then when we kind of transform that and think about what are those apps that are really going to matter? What's going to help us to drive recovery from a standpoint of our completion operations? So Sensori, I want to introduce that to you. This is our integration of downhole diagnostics back into the surface systems. So what is it? Well, it's microfibers. It's microfibers run in offset wells. These are not intrusive fibers like maybe what you're used to, where it's an in situ in the well that you drilled and you're completing. These can actually be run in offset wells that are disposable. They're just little glass rods, and they can break up at the end of the job, and you'll never even know that they're there. It's also a series of looking at pressure pulse technology at the surface, and all of this allows the ability to be able to understand how those treatments are going. And are we effectively treating the perforated intervals that we've actually put into the ground? Are we actually getting the frac to grow where we want it to grow? Can we control that? Maybe not necessarily always. However, knowing that and having that information allows us to make better decisions as engineers. So by integrating the capabilities of Sensori, we provide operators that unprecedented subsurface feedback, enabling them to make decisions based on real-time measurements across the pad. So, is this real? Yes, it's real. We actively started testing this back in 2021, and this was largely using the in situ fibers that were installed in a well. Any of you that have ever done those, they're costly. You've got to change some of the well construction dynamics. You've got to drill a bigger hole. You've got to install the fiber. Very intense amount of information that comes from that, very valuable information. However, it's hard to do that on every well. So we kind of took a step back and said, well, what do we need to be able to do this on a whole pad, to do this potentially on every well? How can we make this more economical? And that's where we got to with the Sensori. So we don't have to install those permanent fibers on the outside of the pipe anymore. We can actually do this being much less invasive and not changing the well construction program that's going into it. So this year, we're deploying the final components to make this real-time feedback-driven completions a reality. Again, this feedback allows completions engineers to make those real-time decisions in order to be able to make changes, when it matters the most, as opposed to maybe months down the road when we're seeing these wells on production. Of course, we're still going to look at that information, but we can actually make real-time decisions at the time and putting the dollars where they really should go. So simplistically, we maybe can look at this as a factory, right? And that's not to take anything away from all the hard work that goes into that. But at the end of the day, what are we doing? We're putting wells in the ground in order to get a product out. So not that much different than what a factory might do from an output standpoint. So when we look at and think about a factory and what really matters in that, so generally speaking in any industry, the greater the distribution and the input materials, the greater the variation in the output quality that you're going to get. In addition, if you don't have any kind of process control or feedback loop of those recurring processes, your process ends up being variable, which further increases that output variability. Now, if we can squeeze down the distribution of that input material that's going into that factory and then close that loop using feedback control to make it more consistent, it seems like we can actually change the output variation that we're going to get. So predictability, understanding what we're going to get from the reservoir is a really important thing, and now the tools are coming around to be able to do that. So again, try to boil this down into kind of simplistic terms, but thinking about that factory, how do we maximize that output? Having these kinds of tools and capabilities is going to help us to make better decisions, drive more barrels out of the ground. All right, so moving on a little bit. I'm going to think about every asset and what do we do for a maintenance program. And so obviously everybody that has wells, they're going to have some form of maintenance that's going on. And I'm not talking about the general workover type stuff, specifically focused here on what can we do to re-stimulate wells? What can we do to add production to wells that are already in the ground. We've made this massive investment in drilling these wells, completing these wells, putting them on production. All these wells, exhibit these hyperbolic decline curves. So what can we do to actually, move that forward? So we look at re-stimulation. And I know it might be shocking to have somebody stand up here from Halliburton and tell you that you should be thinking about re-stimulating your well, but I'm going to tell you, you should be thinking about re-stimulating your well. There's lots of different ways to do it, and there's lots of different reasons to do it. And when we think about it this way, I like simple analogies. So you think about a city that puts in an infrastructure road system, puts in a highway, puts in these side roads, puts in, all the things that need to happen for traffic to flow. If we don't maintain that, if we let trees fall on the road, wrecks happen, potholes form, all those types of things, and we never do anything about it, we're going to create congestion. We're going to create bottlenecks. And that's what's happening in these wells. I mean, we're having debris that's flowing into these fracture networks. We're having, we may have water wetting tendency, changes that are happening over time. We can have lots of different things that are interfering with the ability for these wells to produce. So it just makes sense that we're going to have to do some maintenance over time. So we kind of categorize this in three broad categories, I guess. So re-entry would be the first one. So re-entry is installing a new liner into a well and going back and re-stimulating it just as if it was a brand new well. It's expensive. It can cost, call it $3 to $5 million, just kind of depending on the situation. But where would you apply this? I mean, there's a lot of wells, I think if we're being honest with ourselves, that maybe from some of the early type practices that were out there that we thought were really innovative at the time, we understimulated a lot of these wells once upon a time. There is low-hanging fruit out there from that standpoint to go do that. And this is actually a pretty common practice up here today. Refracturing without re-entry is another method. So this would be a little bit more of a bullhead type technique. So it's going to drop cost. As far as the success rate goes, it can still be very successful. It all comes down to candidate selection, though. Are we looking at the right candidates? How are we viewing this? And how are we going into it? But, you might be spending, call it $500,000 to $2 million, kind of depending on the situation. But again, a lot of success on these. But again, you have to really make sure you're spending the quality time to actually evaluate these wells in the databases out there. And then the last one is remediation. And so this one is something that's been around for a while, but I think it doesn't get the fanfare and attention that it deserves. Our industry has really moved to what we call hydraulic fracturing. Once upon a time when I started with this company, I actually worked in the stimulation department for Halliburton, so we actually called it that at that time. So it was fracturing, but it was also acidizing, it was chemical treatments, it was a lot of other things. We've kind of migrated away from that. There's so much focus and attention over time in the industry to the big frac jobs that I think we've lost a little bit of traction when it comes to some of these more rudimentary chemical treatments, things like that can be done. But not anymore. We're taking a deeper look at that. We've been doing these jobs, but remediation jobs, you're going in, you're working over a well anyway, you're pulling rods, you're having to go in for some clean out runs, pulling a pump, doing something like that. You've already got the well in a condition where it can take some kind of a treatment. You can go spend $35,000, $100,000, and these jobs pay off in a matter of days. Almost inevitably, when you see them happen, they'll pay off in a matter of days. And they won't bring it back to original production, but they will bring it back up to a much higher rate than what it was before the workover happened. And this is an area where we really feel like we can actually move the needle as time goes on. So there are multiple options, but we need to be looking at that because there's a lot of barrels stranded. When we think about, what's going on from the standpoint of the actual recoveries that we're getting on these wells, there's so much more to go get. How do we do that? I mean, we can go in and drill new wells, or we can work on recompleting the complex that we've already created in the ground, the investment that's already been made. How do we maximize that as we go forward? So what should we take from all this? When you consider, the options for asset management, the future is not just what we've done in the past, but finding ways to combine the total operations while capitalizing on the latest technologies. This is the next big step change that can enhance production and operations today while extending the productive life of these wells. Again, we've made this investment. What can we do to extend that? What can we do to extract more from what we already have? So let's continue to embrace that innovation We've shown that we can do it right here in the Bakken. We've been doing this for years. We've been teaching the rest of North America, if you will, and the globe, pridefully I like to say that, how to do this properly, and we can continue to do it. When we think about this, this is so important for us, so together, we can ensure a sustainable energy future for North Dakota by applying the right technologies, by innovating, and further solidify our energy security as a nation. I want to thank you today for having me up here. Like I said earlier, I'm very prideful of what's gone on in North Dakota, not just from a Halliburton perspective, but from an industry perspective. The energy, the enthusiasm, the innovation that I see up here is second to none. And this is a world-class reservoir, but it takes a lot of attention in order to get it done. But very proud to be working up here, and I thank you for having me up here today, and hope you have a good rest of the conference. Thank you.
Thank you, Robert, and thank you for Halliburton for hosting the 5 billion barrel barbecue on Tuesday night, and we appreciate all your support. We're going to take a break. We're going to be back here at 10 o'clock, and we're going to start with the 5 billion video, and North Dakota Governor Doug Burgum will follow that. So thank you to Crusoe Energy for sponsoring the break. So we'll see you back here at 10.